Welcome to the Bracky Factory, and as promised this week I'm going to tell you all about my Lola, and thanks to Ben and JD for the awesome t-shirt. But before we get onto the Lola, we have a bit of unfinished business, of course, and that is with the Austin, and I need to finish the handbrake. So back at the bench, which, let's face it, could do with a bit of a tidy up. All sorts of crap lying around, but anyway, so I've done a bit of work on this, and I've now made a nice stainless rod, put these brass collars on there which are adjustable, and I've got a nicer spring on there. So that's pretty much done now. I need to lock wire these when it's on the car after adjusting these lengths. So that's good. Now I need to work out how I'm going to pull the back. So obviously this lever at the bottom is what actually gets pulled. So what I'm going to do is I'm going to, well, this is a plan anyway, use these Morris Minor cables. So this is the end that goes on the rear wheel cylinder. This is a threaded, I think it's looks to be 1/4 inch UNF, I'd have guessed, 1/4 inch UNF. And there are two of these, so these are both going to need to get pulled. Pretend this is the other one. These are going to have to get pulled by that lever. So that lever is going to swing backwards and forwards and pull it like that. So I need some kind of bar that connects the two, like that. I'm going to use this stuff, I think. I'm going to cut a length of that, so about 3 inches length, drill a couple of holes, and this bit needs to be attached on a pull to the lever such that it can rock from side to side and it can swing up and down. So I need a sort of articulated joint between the two, because of course one might come tight just before the other one, so it needs to be able to rock slightly so it self-adjusts. And obviously as the lever swings it needs to pivot that way as well. So I've got that bar. I've marked out this. I'm going to cut that out and weld it onto there, I think. And I'm going to use a bit of bar, add a bit of bar, yeah, a bit of bar, and cut two slots at 90 degrees to each other, which is going to be my connecting piece. So that obviously that will rotate that way and rotate that way. So let's start making that, shall we? So after a bit of filing and fettling and cutting and welding, we've got this little pull bar and this little connecting block. So if you haven't already worked it out, that connects like that, so that's free to pivot that way. And this connects to the bottom of here, like that. So now this is how will pull. Obviously this bit has to pivot when it goes backwards and forwards, and this bit needs to pivot because the brake cables may not be exactly the same length, and if they're not, it automatically adjusts. So I might have to make that slot a little bit deeper depending how far back the lever comes. I think it's going to be okay, but it would just be a case of filing that out. So now stick this on the car, I think, and turn my attention to the back end where it pulls on the wheel cylinder. So I'm back at the bench actually. So I put it on the car, and what I've found out or realised is that these two holes weren't wide enough, because I would have had to drill a hole in part of the cross member which I couldn't drill a hole through because I had a bracket in the way. So what I've done is make a wider one. Here's one I prepared earlier, and I've actually changed the design slightly in that I've now milled 2 slots in the bottom, and that's so that you've got a certain degree of sort of rocking motion there if they're not the same length. And I've machined up these little half round sort of bobbins, and they're threaded, and it's actually quarter BSF. I was surprised, I thought it was going to be quarter UNF. And now these rock in here like that, and the idea is to put a lock nut against there. I might even weld on a little shoulder just here so it actually stays at 90 degrees. Not sure yet, that might be a bit of overkill. So having done that, I'm going to go back and stick it on the car. So I've put the lever back on the car. It all seems to be fine, but of course I can't really test it until I've sorted out this end. So this is the cable, and this is the end of the outer. So I need to make a bracket that goes on about there. Now I was going to use the indicator bracket, but sorry, the brake light bracket that was here. There's no way that's going to be strong enough that you can generate so much force with this. So I'm going to have to fabricate a bracket and weld it onto the axle, ideally in situ, because it's a big job to take the axle off. So I've got various bits of cardboard. I'm going to sort of have something sort of like that, with a bit coming out here and sticking up, and a hole, and it's going to go through there. I might bend this slightly over that way so that it comes in close to the axle. But brackets is what we do, so I'll now fabricate a bracket. So about 30 seconds later, and we have a bracket. In fact, we have 2 brackets. And this one I've clamped to the axle where it's going to go. All I have to do now is weld it on, which is easier said than done, because this axle is pitted and has been powder coated. So getting all of the pits and rust out, well, not the rust, but all the pits and all the paint off, is easier said than done. I've used a grinding disc just to grind away the top and get down some bare metal. So need to create a bit of space, get on my welding gear and weld it on. Oh, we've got a cat. Cat has come to help. So after a lot of crawling around, trying to weld upside down, both brackets are on, which is quite good. So we're getting there. Next step is to make these cables shorter. A, they have to be different lengths, and B, they're both too long anyway. So let's get cracking on that, shall we? So So that's now soldered on. I actually used silver solder, which is this stuff. Johnson Matthey Silverflow 55 melting range is 630 to 660. So as you can see, it takes quite a lot of heat, but this is now completely bomb proof. I could quite happily hang the car off that, I reckon. You might be thinking, why didn't I machine some flats on that? I probably will machine some flats, but I'll machine them so that they're in the right handy plane for a spanner, so I can stick it all in the car and then be smart where I want to machine them. So yeah, I think the time has come. Stick it on the car and see if it actually works. So here it is in the warm light of day. So that's the lever. Underneath here is the mechanism which is used to pull everything together. And if we just move around the back, obviously the back under tray is off at the moment. You can see how all of the cables run, and they run through to there, the brake lever, and you can see everything else that's going underneath there. Back axle, brake lights, etc. And so, oh look what we've got. We've got a little friend to help us. So now let's give it a quick test, shall we? So the handbrake is on, and if I push the car, it's pretty solid, and obviously to take off, all I'll do is pull it, and it comes off. So I'm quite happy with that. I can even use the handbrake to slow down, which is pretty good considering it's 1930s technology. But I think that's enough of the Wragg for now. I think it could be time to go and check out the Lola. So this is her lockdown Lola, as she's now known. So let's have a quick flyby. There's the motor. Let's walk around the front, shall we? Have a quick look. There she is. Right, let's talk about a few of the bits. So let's start off with the chassis. It's actually a race car replica chassis made by a company called Race Car Replicas in Detroit actually, and it's TIG welded aluminium plate. So the original was aluminium. This is obviously aluminium. Obviously a bit heavier than the original, but obviously a lot cheaper to make. So I got this from Race Car Replicas about 10 years ago, and it kind of comes as a kit, but you have to use the word kit very, very loosely. It also has Race Car Replica, so it was a rolling chassis, so upright suspension, and it's all very, very big. Compared to the Austin 7, it is massive. Engine and box. So the box is a Porsche G50 gearbox. It runs inverted because normally in a Porsche it's the other way around. Points forwards, so you have to invert it such that you don't get 5 reverse gears and 1 forward gear. The engine is a small block Chevy. Now they originally ran a 5 litre, this is a 6.3 litre, so it's a stroker engine. It's got some slightly hotter cams, but that's about it. And these are Weber IDAs, 48mm IDAs, on a rather intricate throttle linkage that took me absolutely ages to make. The gear linkage is one of my proudest achievements and also the most fun to make. So all of this lot has been devised because I didn't want to have a cable gear change. I wanted to keep it a rod gear change as used in the original Lola, but of course because the this input is facing the wrong way. I had to transpose forwards to back and anti-clockwise to clockwise, so hence this complicated looking mechanism. I might show you that in a minute. This is what the gear shift looks like inside. This is actually a Lola gear shift, which I obtained from the company which makes the continuation Lolas. I think it's called Fox Racing. Over here we have this sort of fabricated box. Now this is pretty much the same as fitted to the Lolas. You would have an oil cooler in here. It's not got one fitted at the moment, but also I've got twin fuel pumps in here and a fuel pressure regulator just here. Underneath there, down inside there, is a collector fuel tank, and in this side panel inside here underneath there is a long thin tank, and here is the filler. Dirty great big thing. The bodywork is original Lola T70 Mk3B bodywork, so it has the forward swinging doors as opposed to the gull wing doors of the Mark III. It was a bit of a pig to fit all of this. It takes a lot of filing and fettling. The doors have to be made up of the separate panels and bonded together. Many hours are spent on doing that. Not quite finished at the back. I still need to fit the inner arches properly and fabricate the ducts for cooling the rear brakes. This is the interior. An awful lot of time was spent on this interior to make it look and feel as much like an original T70 as possible. Now sitting inside the car, and I used a lot of reference photos to try and make it as accurate as possible. So all of this dash, everything had to be fabricated. You don't get any of this stuff with an RCR70. So let's switch it on, ignition on, and all of a sudden lots of lights come on. So we've got in front, we've got a temperature gauge, rev counter, oil pressure gauge. Of course we've got no speedo because T70s didn't have speedos. That is your oil low pressure warning light. Over here we have got start button. We've got two fuel pumps. I'm going to switch them on, and also this is the reserve fuel pump, which pumps fuel from a reserve tank, which is actually built into the main tank, into the collector tank. Over here we've got the plumbed in fire extinguisher. We've got a fuel gauge, which is not the most accurate thing in the world, but it's better than nothing. Over here we've got all sorts of other gauges. We've got amps, volts, temperature, lights, main beam. We've got two fans, and we've got a switch which means they will automatically come on when I reach a certain temperature. What else? I've got a horn there. Oh, that works. I've got windscreen wipers. They work. So hazard lights. What else? Not a lot really. Obviously that's quite an exciting switch. That's a start button, so we'll start that in a minute. Once I start this thing, I'm going to have to evacuate all areas straight away, so before I do, I'll show you the gear linkage. So I'm inside the car now. So this is your neutral plane. So I've got first, second, third, fourth, fifth, and reverse, back into neutral. So after that whistle stop tour, it's time to start it. So starting procedure is turn the ignition on, turn on one of the fuel pumps, that's fine, get some fuel pressure going. The carbs, there's no choke, so give it a couple of squirts. 1, 2, maybe another one, 3. It's got accelerator jet, so it basically squirts neat fuel in. And press the start button. that was 2000 RPM and it revs to 6. So I hope you enjoyed that. If you did, please hit like. If you've got any comments, please do leave comments. I try to answer them all. I've got all sorts of exciting things planned for some of these cars. I'm also doing some more work with Brian down at Oak Swamp, so if you want to know anything about that, please hit subscribe. But for now, thanks for watching.